Hello everybody, this is Fatima and today we are going to build our own IoT product. So, I'm going to talk about Internet of Things or IoT for this interactive tutorial. What is IoT? The name may sound strange, but IoT or Internet of Things are everywhere and the number even has surpassed the human population. They are disguised under common everyday use objects, and right now we are drowned in technology supporting Internet of Things. As the name suggests, two important components for IoT or Internet of Things are things and internet, meaning connectivity. These are physical objects that are connected over the internet. And what do they do? How they do it? Basically, they exchange data, and they exchange data because because of that internet, and they collect that data by using sensor and software and other technology these things have. Smart objects are capable of talking to or interacting with one another. Why do they do it? So this is one very important aspect. We already have like maybe thermostats to control, but these devices also help us control and monitor remotely to perform actions automatically without being physically there with the device. So that's one huge step in that sense. Examples range from ordinary household objects to sophisticated industrial tools that we are going to look into in a second. These devices are growing rapidly, and experts are expecting this number to grow to 22 billion by 2025. Now, this has created a hyper-connected world. This digitally hyper-connected world has these objects which are digitally connected, and even though these objects are physical, but they are generating and continually adding to big data by recording, monitoring, and adjusting each interaction between connected things. The good part, physical world meets the digital world and they cooperate. I know most of us don't like to look into the history, but the history of Internet of Things is not history, it's the recent present. Let's take a quick look and see why it's important. So in 99 the term was first time coined, but at that time they were not using internet, they were using RFID, a different technology for connectivity. 2000 was the year when we got our first smart fridge, but it was too expensive and it was a miss, not a hit. That's an important factor. If you want something to be popular, we want it to be accessible, affordable, like by masses. 2004 was the year when we got our first smart watch that showed emails and weather. It got live, data, but we couldn't respond to those emails. 2007 was the year we got our first smartphone. Now we cannot imagine our lives without smartphone, not for a day, not for an hour, but life was a different story before 2007. And I'm assuming some of you may have, I think, born around that year. 2008 was the year when devices surpassed human population. In 2009, we started research on self-driving cars. 2011 was the year when the term actually started gaining popularity. Before that, we were working on smart devices, but Internet of Things wasn't a popular term. So 2012 marks a very important year because cloud computing became accessible and improved visibility of IoT. So cloud computing is basically, they are platforms you can imagine, really powerful computers in a building, not in clouds, of course, and we being connected to them. So let's take example of our computer or our laptop. We have like certain degree of computation power and storage with these computers and laptops. If we want to go beyond that, We don't really need to go to a place with those powerful computers. We can just connect our computer to the cloud computing platform, which are managed by professionals, and we can use their platform for better performance and better results. In 2014, we got our first Alexa release that surged towards smart homes, and at this point, I would say that Alexa is younger than you guys. I think most of you were born before 2014. So we are here in 2022. Today we are gonna build our own product, and I'm not gonna talk about, like, you guys have to decide the future of this thing. What technologies have made IoT possible? Low cost, low power. So cost, just like we discussed, is one major important thing, and we got low power required sensor technology, connectivity, internet is everywhere, and it became really a big thing, which facilitated this Internet of Things. Big data has helped us, teach our machine learning algorithms and come up with better models. Cloud computing has facilitated with all the computation power we need, artificial intelligence, physical things, portable technology, and automation that has given us with minimal human intervention. Why can IoT attract people's attention? One, quality of life. We can share anything with our friends, family, even if we are not in the same city. We can share a party or any other stuff. Not just like the social media things. We can track our health. We can track how many steps we took, the quality of our sleep, or our diet. So basically, it's helping us improve quality of life. Services and management. Let's say we have a house that is smart home, and we have a house without all these IoT devices. In a house without this smart technology, if there is any leakage, we are going to find out once we see a big spot like water stain on the floor or on the wall or on the ceiling, and realize something is wrong and I need to take care of that. Imagine a smart home. There are sensors everywhere that are monitoring and managing everything. And if there is something not working or there is some leakage, your devices are connected to that cloud platform, and your mobile is also connected to the platform. As soon as something happens, you're going to get notification on your phone that something is not working or leaking, and you can immediately look into the thing, and you can save yourself from a big stain that you need. Maybe use a carpet to hide, maybe repaint the wall or redo the ceiling. So services and management is another important factor that makes it attractive for people. Technology has a tendency to have a negative impact, like carbon dioxide, cars release, and all that stuff. But Internet of Things are helping us monitor our environment, like air quality, and have a positive impact. And this is one of the major attraction, as we need to save our environment for our future generations and other living beings on this planet. IoT application is like in everyday life. We have wristbands for like maybe monitoring our health, like a security band to enter places like Disney World. They have their own magic bands. We have sensors that we can ingest for health reason. We have so many smart home devices like smoke alarms, home controls, air quality monitors, learning thermostats, and we also have things like baby monitors to help us in our daily lives. Other than like smart home, the scale changes quickly, and we can have like smart surveillance. We can have power grids that control the flow of current. We can have a smart parking app. You can imagine how bad the parking situation is in cities like New York, and you get a notification on your app that's XYZ is the spot where parking is available, and you can save time and just go there and park your car. We can avoid accidents by getting warning related to maybe some blockage or pothole or anything. And one of my favorite research, we all love animals, not are just pet animals like dogs and cats, but wild animals too. But it's not always wise to interfere their habitat. We often need to take care of that, but we cannot be physically present as it may be harmful for them and for us, like dangerous as well. We can use technology like GPS to track their habits, track their walking habits. We can use drones to learn about their behavior. So without intervention, we can learn about animals and we can help them. What's the future? I'm not going to talk about future. You guys are going to decide the future. Now I hand it over to Jonathan.
Hi, I'm Jonathan, and I'll be presenting the second part of this presentation. In this section, we're going to be going over what are Arduinos in general, how Arduino works, what goes into and also we're going to talk about basics of circuits because Arduinos are circuits, and finally we'll talk about applications of Arduino and how we use them in some of our current projects and case. So first things first, what is Arduino? So Arduino is an open source hardware and software company that manufactures a variety of single board controllers and also microcontroller sensors, which are used to develop and build a variety of digital systems. Of course, Arduinos are programmed with C language, and custom codes are created and can be extracted from either the internet or whatever sensor pack you have, and those are like extracted and adjusted to run and obtain data from plugged-in sensors within the Arduino. So on the left here we have the microcontroller board, which is one of the more popular boards that we use when using Arduino systems, which is an Arduino Uno. In the center, we have these sensors that are created by Elegoo, and these sensors are plugged into the Arduino board, and those will pick up certain kinds of data, which we'll talk about later. And finally, on the right is a very basic rudimentary interface of Arduino showing rudimentary code, of course. So first things first, how does this all begin and such? So first, we have to talk about the idea of publishing. So publishing is essentially what is the Arduino board trying to get out of this, or like what kind of values are you trying to get out of it? So in this case, you can do a lot of, with Arduinos, you can extract a lot of values. For example, you can extract temperature, you can extract humidity, you can also extract other things such as proximity, CO2 levels, depending on the sensors that you have. In this case, you guys have humidity and temperature today. So you guys will humidity, temperature, and CO2, I believe. So you guys will be able to work with that in particular. So that's what you'll be publishing. So after determining what you publish, you have the sensor that plugs into the controller. And that more or less, so essentially what happens is that this gets plugged into the microcontroller that you're going to have, which is an ESP8266 Adafruit, which is essentially a different kind of Arduino Uno, but they still use the same application in order to run and to program and run. Sorry. So in this case, on the left is a proximity sensor, and the right is the Adafruit sensor. So that needs to be plugged in before we can start actually collecting data. So after the collection is after the data is collected, the Wi-Fi chip on this Adafruit board will be subscribing information, will be sending data into Adafruit, which is subscribed to information that is coming from the Adafruit. So subscription is essentially similar to YouTube. It's like you're trying to follow something, but in this case, subscription here is like following the data that's being collected by the board. Finally, so essentially, what over here we have an interface showing temperature, humidity, and date data. And of course, this will vary depending on the sensors that you have and the data that you're collecting and subscribing to. So then finally, this is going to go to, so in this case, you guys are going to be getting notifications from an app called IFTTT, or or this app that uses IFTTT process. And pretty much it's like if this value exceeds this amount, then you'll get a message. So in this case, let's say you guys wanted a temperature. If the temperature rises above 80 degrees, then you guys will get a message. Well, in that case, that's what this app is pretty much going to do. So if the subscribed data, so in summary, if the subscribed data says, hey, if your temperature, for instance, is above 85 or something, then you'll get a message saying, oh yeah, it's above 85. So that's the final step of this. Okay, so essentially, in order to understand how Arduinos work, or the basic concept of how Arduinos work, we have to understand circuits. So a circuit is essentially a closed path in which electric can flow. So all circuits must have an energy source, which is essentially the voltage, along with a rate of which energy flows, which is current, and a form of resistance to the flow. So the basic equation of this relationship is voltage is equal to resistance times current, which in short is Ohm's law. So on the left here is an Arduino board plugged into a waffle board, an Arduino board, sorry, plugged into a waffle board with a bunch of components, and that's a very complex form of a circuit. But to dull it down, in the center we have a more simple circuit, which is the battery, the switch, and the light bulb, which acts as a resistor here at some degree. And on the right, we have Christmas lights, which is a very good example of a circuit that we see everywhere. So how does electric flow? So it's really important to understand this because when formatting the Arduino and formatting the Adafruit sensor or the Adafruit microcontroller you guys have and such, you have to make sure that the positioning of the wires is very important. So when circuits flow, like all energy circulates from the negative side and goes to the positive side. And that's because of natural properties of equilibrium homeostasis. Electrons want to flow to the positive side to even out the net charge on both sides. So that's why batteries pretty much run out of power eventually because the electrons are essentially neutralizing the charge that's contrasted within the battery. That's why batteries have a negative side and a positive side. Now, when it comes to making Arduinos in particular, you have to plug it in and you have to plug these in a way where it's the Arduino, the negative side to the sensor, and then from the sensor to the positive side of the Arduino, or the positive part of the waffle board in particular. This is really important in order to prevent malfunctions with your sensors and such. Um, so okay, so of course, why do we need resistors? So if we don't have resistors, then short circuiting can occur. So essentially, without resistors, current can get too high, and that will ultimately cause short circuiting, which damage circuit components. So resistors are installed in circuits in order to reduce the flow of current to safe levels. Um, so if you short circuit, you can potentially damage your sensors that you may or may not have, but more importantly, you may damage your microboard, which will be very costly to replace or somewhat costly. So an analogy of this is like a water slide you go to at a water park. So there's a reason why lifeguards are on the top is because they're trying to regulate like the amount of people that are going within that water slide in a certain amount of time. So let's say everybody was running through the water slide all at the same time. Well, that means that a lot of people are going to be, clogging up. There might be potential clog ups and malfunctions and such with the overall experience of sliding down the water slide. So that's why let's say so now let's put this into circuit terms. So let's say the lifeguards are the resistors controlling the flow, and the people that are going on the water slides are like the flow itself, so current. So essentially, the resistors are balancing the current, so there's like a stabilized flow within it. Like if there's too much resistance, then nobody's going to go on the slide. But if there's too little resistance, then the slide's going to be bound with a bunch of errors and such. Errors, not errors, sorry, but bound with problems in time to come. So where do Arduinos come in? So as I said earlier, Arduinos are these circuits, but instead of like the light bulb, for example, where this destination of voltage is going to, imagine more complex things like your sensors and other things that you could plug into Arduino. Those are like the parts of the circuits that you guys are going to be essentially making, and you guys are going to use these sensors to interact with the Arduino interface and such. And ultimately create the data that you're going to make today. So, what are some applications of Arduinos from our studies in case? So, one example over here is our is the second iteration of our Friendship Cabins project, which is located in Brooklyn. So, in this case, we used sensors such as CO2 sensors, proximity sensors, and such to enable a light system and such. So on the right over here is kind of a very complex way we designed a case for the Arduinos in order to make sure that no water gets in and such. And that's just opened up to see the parts in particular. So, okay, so I'm gonna go to the YouTube video right now. And all right, whoops. All right, and this should show the LED interaction over here. So there's me blowing into the carbon dioxide sensor, and eventually this light over here is going to react in order to create like a light spectacle or a light show respective to that. It does take some time though because of course like the board is or the Adafruit interface is subscribing to this data, and the data takes time to go from the sensor all the way to the computer controlling it. So, of course, this is that goes on as a result of that. So, yeah, this is an example or a demonstration of what we've been doing at Case. And I'm going to pass it on to Ji-hoon to explain his BIM and Arduino research. All right, thank you.
Hi guys, I'm Jihoon Chang. Let me explain my research project. In this project, I developed a monitoring system using IoT sensors and built the information modeling database. Using the sensors and database, we can understand where the air pollution occurred, where does it come from, and how to mitigate it. Also, the system can push notification on the occupant's phone based on the seat information. Let me walk you through a tutorial. In this tutorial, we will learn how to build your own IoT system that monitors indoor air quality and thermal comfort and pushes notification on your phone. At first, we will build your own sensor module. The sensor module collects data and forwards to Adafruit dashboard. If the value exceeds the specified threshold, it will push notifications on your phone. Because of the limited time of this tutorial, I have you already installed software and created accounts as I described in the handout. If you didn't, please download and install Arduino software on your laptop or desktop and install IFTTT application on your phone. Also, create accounts on Adafruit and IFTTT websites. Finally, identify your Wi-Fi SSID and its password. These materials are needed for this tutorial. First, Adafruit Feeder Huza is a wireless Arduino board, and DHT11 is to measure temperature and humidity data, and breadboard and jumper wires are needed to connect the board with sensors. And micro USB cable is for uploading code files and supplying power to the board, and SGP30 is to measure VOCs and CO2 gases. 4-pin to main headers cable is to connect SGP30 sensor with the board. This slide shows feeder Huza pinout and the principle of breadboard. You don't have to understand all the pins in the feeder Huza, but just several pins for this tutorial. 3v3 is used for supplying power to the board, and GND is used for connecting the ground in the circuit. 254 is just the pin number, but these pins used for sending or receiving data from the sensor. Breadboard is the simplest way to construct electronics without having to use the soldering iron. In the breadboard, there are two kinds of strips. The vertical one means bus strips, which are mainly used for power supply connections. The second one, horizontal line, means the terminal strips, which are mainly used for electrical components. Okay, let's build a sensor module. If you need any help during this tutorial, please feel free to send me a message. We will help you to follow the instruction. At first, connect Adafruit board to breadboard. Then connect 3V pin to plus line. And connect GND pin to minus line. On each T11 sensor, there are 3 pins. Keep in mind that the order of pin depends on sensor manufacturer. Check symbols on your sensor. On my sensor, left side is plus pin and right side is minus pin. Connect middle one with pin number 2 on the Adafruit board. On SGP30 sensor, there are 5 pins. Among them, we will use 4 pins. Connect VIA pin with plus line. And GND pin with minus line. Connect SDA pin with pin number 4. And SCL pin with pin number 5. And now building the sensor module is done. Let's set up Arduino IDE. At first, we will insert additional board manager URLs on the software. Click the right button and copy the link and open the software. Click the file, click the preferences. At here, there is the additional board manager URLs and paste the link and click the OK. Then we will select the board, click the tool, and click the board and board manager, and write down the ESP8266. Then there is the ESP8266, and click the install button. Then it is the installation complete. And again, click the tool and click the board, and there is the ESP8266 board tab. Click this tab, and there is the ADA fruit feeder HUSA a ESP8266. And click the button. Then connect your sensor module with your laptop or desktop using the USB cable. If you connect your sensor module, then click the tool and click the port and click the button. But this number can be different, depends on your USB port. And now install libraries. Click the tools and click manage your libraries. Then write down ADA for IO Arduino. Then there's a lot of libraries, and find the Adafruit IO Arduino and click the install button. Next one is Adafruit MQTT library. Click the install button, and then next one is Arduino HTTP client. Click the install button. Next one is Adafruit SGP30 sensor. Click the install button. Last one is DHT sensor library. Click the install button. Then setting up is done. Let's download the file. On the fly, click the right button and copy the link. And open the browser, copy the link. And download the file. If you download it, unzip the zip file and click the folder and double click it. If you open it, there will be an alert window. Click OK. Then you can open the code file. In the code file, you don't have to understand all the code. Just write down Wi-Fi SSID, Wi-Fi password, IO username, and IO key. If you don't know your Wi-Fi password, find your Wi-Fi router. On the back, there will be a SSID and its password. To get your IO key, you need to sign in Adafruit website. Click this link on the slide and open the IO Adafruit website. And click the sign in and write down your email and your password. And click the sign in button. And on the tab, there is a MyKey and click it. Then you can get your IO username and IO key. Copy this code and paste it on your Arduino file. Also, write down your Wi-Fi SSID and Wi-Fi password. Then click the upload button. To check the your sensor works well or not, click the Tools, and click the Serial Monitor. To reset your serial monitor, click the Reset button on your ADA breadboard. Change the valve into 115200. Then you can check the data from the sensors. The data is collected for every 10 seconds. Okay, then let's forward the data to the ADA dashboard. Open the browser, click New Dashboard button, write the dashboard name, and click Create button. Then the new dashboard is created. Let's create a gauge chart. Click the Setting button and create new block. Click CO2 feed and click Next step. Edit gauge min value and max value. And click Create Block button. Then CO2 gauge chart is created. It's so simple. And let's create TVOC gauge chart. Click TVOC feed and edit gauge mean value and max value. Next, let's create temperature line chart. Click temperature feed click Feed key lessened. Then the new line chart is created. And create humidity line chart. Click Feed key lessened. Here you can edit charts after creating the blocks. Click the Setting button and Edit block. Click Next step, change Show History into Live to show real-time data. Click the Setting button, click Next step, change Show History into Live. If you want to change the block layout, then you can drag and drop the blocks. If you are done, click Save Layout button. Now you can see that the blocks show real-time data from the sensor module we built. If you follow the wind to DHT11 sensor, the temperature and humidity value is changed. Okay, great. Then let's connect to IFTTT application. Click the link and open the browser. Write down your email address and password and log in your account. Let's create your applets. Click the create button, write down Adafruit. Then you can see the button. Click monitor a feed on Adafruit IO. Here, we will build our own system. If humidity value is greater than 60, IFTTT app will push notification on your phone. Select humidity feed. Relationship is greater than. The value is 60. Click then that button. Write down notification. Click send a notification from the IFTTT app. Then just create action. And click finish button. Let's check if our system works correctly. To increase the humidity value, I blow the wind to the DHT11 sensor. Then the humidity value becomes 95%. The system push notifications on my phone. The message is humidity 95 is greater than 60. If you want, you can change the message whatever you want on IFTTT website. Let's wrap it up. Because of the limited time of the lecture, this tutorial can quite intensive and fast for you. This lecture has been recorded and will be uploaded on RPI YouTube. You can watch it and catch up the instruction at your own pace. If you have any question on this lecture, please feel free to send us email. We would happy to help you. Thank you for listening.